All right, problem 1 from our review says, given the following graph, consider the transformations applied to a parent graph and write the appropriate equation. Then state the domain and range of the function in interval notation. So starting out here, it looks like we have a square root function, and we know the parent equation for a square root function would be something like y is equal to the square root of x. And when we think back to the actual parent graph there, right, our critical points that we usually start with would be like 0, 0, 1, 1, and 4, 2. So if we think about where those would be located on the graph, we'd have 0, 0. We'd have a point usually at 1, 1, and then we'd have a point at 4, 2. So our parent graph would look something like this as it's coming up, right? So in comparison, right, obviously our graph has been moved to the left. We've gone back, what, 1, 2, 3, and then we've gone down, it looks like 1, 2, 3, 4. So we went to the left 3, and we went down 4. But one of the other things I want to focus on here is, has this graph been stretched? If we look at the point that is, this is like our end point that's been moved here, but if we look as we go over 1 to the right, when we go up, we've only gone up 1 unit on our parent graph, but here if we go 1 to the right, we've gone up 1, 2, which means that this graph has a stretch factor of 2. So as we're trying to rebuild the equation here, we know here we'd have a y is equal to, well, since it's been stretched 2 units, we'd have a 2 times our square root. And since we've gone back to the left 3, means we're going to add 3 inside the square root. And then afterward, we're going to have moved down 4, so we're going to say minus 4. So our transformed equation that you're looking for should be y is equal to 2 times the square root of the quantity of x plus 3 minus 4. Looking for the domain and range of our new graph here, our transformed equation. Okay, so we're starting here, and for our domain, we're starting, it looks like, at -3, and then it kind of creates its shadow along the x-axis that way. So we're going to say here that it's going to start at -3, and we're including that value. And it's going to go forever, right? So if we imagine there's an arrow on the end there, it's going to go to infinity, and then we'll close it with a parenthesis. For our range, I'll use green here, right? Thinking about the shadow that it casts on the y-axis. So it starts down at -4, and it will continue to go up forever. So our lowest value would be -4. We're going to include that point, and it's going to go towards infinity because it's going upward forever. And we'll close that with a parenthesis. That is problem number 1. If you have questions, make sure that you bring them to class.